from. And in this presentation, I will talk about the NoType project and its goal. I will present you the main knowledge bases in the digital humanities research field. I will talk about the challenges and the issues in this research field. I will present you the NoType graph solution and the technologies behind it. I will describe the system and I will show you a practical example where I demonstrate how NoType graph can help ancient documents and symbols researchers to find historical implication through a specialized tool. Finally, I will talk to you about the future works. This work represents an essential research step to run to the main challenge expressed in the European NoType project. Investigate the graphic symbols to capture all the possible historical implications by studying their graphic execution and their models. With NoType graph, we can achieve this by building the NoType knowledge graph and the NoType graph interface. Building the NoType knowledge graph, we want to share a common understanding of the structure of information among papyrology researchers, enable reuse of domain knowledge, and make domain assumption explicit. While building the NoType graph interface, we want to explore all the knowledge extracted in the knowledge graph NoType, allow researchers to search and explore relations and connections between resources, make historical implication, and finally discover new things. Many works face the challenge of creating semantically enriched knowledge bases to view data under new perspectives and discover hidden implications by searching and visualizing those data. This slide lists and describes current use of semantically enriched knowledge bases in the digital humanities. For example, Pleiades contains data about the ancient world geography. This system provides a semantically enriched formats of its data, but doesn't allow the query of those data through a Spark endpoint. Then papyri.info contains an electronic corpus of ancient papyrological documents and related materials, but like Pleiades exposes its data but doesn't allow the query through a Spark endpoint. Trismegistos is a metadata platform for the study of text from the ancient world. Contains documents, people, and places, but do not currently provide a data expert feature. It does share its data by papyri.info in the form of periodic database dump. All of them have embraced the link open data as a means to connect their data to the broader digital cultural heritage infrastructure, but have at the same time avoided the complexity of attempting to represent the full range of data as RDF. Some of them have tried, but it's impossible to access their resources without spending a long time preprocessing, mapping, and integrating with other vocabularies and knowledge bases systems. Today, there isn't a knowledge base about ancient symbol for papyrology researchers, and there isn't a RDF schema and a tool to represent completely this domain. The main feature of NoType graph is the visualization of the knowledge graph-based original contents inserted by researchers and the full integration and accessibility of these contents. In this slide, I will explain what are the technologies that allow us to build the NoType graph tool. The Resource Description Framework, RDF, is a standard model for data interchange on the web. RDF offers the ingredients necessary to build a giant global graph of data, where individual documents describe part of a data graph that can be interlinked to form a cohesive global graph of data. While RDF terms are used to identify resources, RDF triples are used to describe resources. Vocabularies provide a set of classes and properties to describe a given domain user the RDF's handout standards, and make data integration easier by reducing diversity in describing things. For example, in the NoType graph, we have defined one new vocabulary and we use 8 existent vocabularies. New vocabulary regards, for example, symbols, documents, elements, shape, and positions of the symbols in the documents. And existent vocabularies regard the images of the symbols, coordinates of places, description of the resources, etc. In this slide, I present the design of the notigraph system, able to offer a novel service, discover historical implication of graphic symbols. The papyrology researchers insert and update data in the Notai database through the Notai interface. Then we start from querying those data to extract all the relevant data in the papyrology research field. Subsequently, we analyze data and build software to automatic processing this data. We have defined a vocabulary and reused existing to describe all domain. We apply the data model to define the RDF scheme of all data. And finally, all semantic data will be accessed either directly through a web service, a Sparkle endpoint, or through the visual user interface. Although existing work with aspect of the system proposed here, our system is novel in being designed from ground up to offer the knowledge graph-based access to the ancient documents and symbols. The user interface is novel in adaptive visual in data exploration as a means to search in a corpus of content. For each step, there are existing components that we adopted or new components that we are developing. For example, for the triple store, we're using BlazeGraph. To map in data, we use a Python tool which preprocesses, clean and maps the CSV output of PostgreSQL to RDF standard. The web frontend is developed using the React framework for its modularity. We reused the Arca frontend and adapted it to this context of use. I want to show you a video to discover historical implication with the notigraph tool. For example, we are looking at two resources. In this case, are two documents. Then we open the tracepath tool component to looking for the elements in common of these two types of resources. We discovered that the provenance of both is undefined and both are documents. Then we can continue to browse the system, and we can drag and drop all the resources from the results that we have found. For example, we can explore the loan contract, that is a document. We drag on the board the papyrus, which is the provenance of this document. And then we are looking for all the documents coming from the papyrus. And we can, this type of researchers on people, places, documents, symbols, etc. In conclusion, in this work, we present the vocabulary construction that describes the domain of ancient documents and the symbols in them. We also presented a visual search tool adapted to this context. The single search for a term or parallel searches that show resources connected by semantic relationships support our hypothesis, find a historical implication between multiple instances of classes or between documents, symbols, languages, places, etc. The next goal concerned the extension of the vocabulary to all the elements of the Notai relational database, the construction of an adapt tool to show and search documents based on geographical location, integration with other existing database and knowledge graph, like Trismegistus, Pleiades, etc., and an evaluation of the system with a classroom of students. Thank you for your attention.
Thank you, Eleonora. Any question from the audience? We have time just for a short question. Any question? So I have a question. Eleonora, I've seen that you have used many different tools for the different aspects to be addressed by your implementation. Have you had any problem in the cooperation, in the interoperability of those tools? Any specific problem to address?
Now we haven't found any problem to integrate all of these technologies. This is one of the main particularity of our pipeline, that can integrate all of these technologies in an automatic way. This is the main function of our system.
Perfect. Thank you very much for the
Thank you so much.
Thank you. So now